There are two things to do in this problem. First, I need to find the vertical asymptotes. And second, I need to describe the behavior of the graph to the left and the right of each vertical asymptote. So here's my function. And I'm looking at it, and I see that it's a rational function. I have a polynomial on the top, and I have a polynomial on the bottom. So there's no logarithms here. The way I'm going to find a vertical asymptote, or I'm going to have a vertical asymptote, when my denominator here is equal to 0. So I need to figure out what values of x would lead my denominator to be equal to 0. Well, I think I'm going to start by graphing this. And I already entered it into my calculator here. And I'm going to go zoom 6. And here comes my graph. And I see I have a couple of vertical asymptotes. It's hard for me to tell exactly where they are. So I want to kind of zoom in on that. It looks like all the action is happening, say, between -4 and +4. So of x, I'll change my window to be -4 and +4 for my x values, and I'll graph it again. And sure enough, so it looks like I have, that's an ugly graph. I fixed it. I changed my window so that I didn't go out to 4 on the right-hand side of the x. I made it 3. I just needed to change it up because for whatever reason the calculator was acting up, and these pieces right here were not showing up. But I knew that they were there. And you should know that they're there also, because just because your knowledge of graphing and algebra should tell you that they should have been there. Good idea to kind of refresh your graph and see if you can get it to look right. So it looks like I have one vertical asymptote that is somewhere between 0 and -1. And it looks like my other vertical asymptote is at 2. So I'm just going to write that down. I'm going to say it's going to be, I have a VA that's less than 0 but greater than -1. And I have another vertical asymptote that looks like it's approximately 2. And the way I'm going to find out exactly where those are is I'm going to factor this expression. So I'm going to factor this to find out what my zeros are. And I'm going to do it using the surefire method of factoring, which if you don't remember, there's another video on this, but this is how you do it. You take, it's a quadratic expression in standard form, and I take the first term and I multiply it times the last term, and I get -20. And then I have to find factors of -20 that when I add them together will equal -8. So I just generally run through factors. So I might look at, well, what about 4 and 5? I can make those equal -20, but no way I can combine 4 and 5 to get me -8. But maybe I'll look at 10 and 2. Oh, and I see that I've hit it, because I can have -10 and +2 that will, when I multiply them, they give me -20. When I add them together, they give me -8. So I'm going to write this here as 5x squared minus 10x plus 2x minus 4. And all I have done here is taken my -8x and divided it into these two pieces. But by doing so, that allows me to group this. And so for this first group here, I can see that I can pull out a 5x. So I take out a 5x, and I'm left with x minus 2. Plus, in this second group here, I can see that I can pull out a 2, and I get x minus 2. And using the distributive property, I can now see that this is the same thing as x minus 2 times 5x plus 2. And if I set that equal to 0, I see that I have one 0 at +2, and another 0, it looks like, at -2/5. And that seems to fit with what my graph is showing me over here. I would have a vertical asymptote at -2/5 and a vertical asymptote at +2. So I've rewritten that on the page where I was working the problem, and I've rewritten my function in factored form, and I've identified here what I think are the vertical asymptotes. I could go ahead and confirm that using tables, but I'm pretty comfortable looking at the graph and with the algebra that I just did. So now I have to describe the behavior as the function approaches each of these vertical asymptotes. So let's start with the negative 2/5. So my limit as x approaches negative 2/5 from the negative side of f of x is equal to, well, as I'm approaching it from the negative side, you can see maybe over here I'm on the graph, it's positive infinity. And my limit as x approaches negative 2/5 from the positive side of f of x, if I'm approaching negative 2/5 from the positive side, it looks like it's negative infinity. Now my other asymptote, my limit as I'm approaching, as my limit as x is approaching 2 from the negative side of f of x is equal to positive infinity. I'm coming at it from the negative side, and I'm going positive right there. And my limit as x is approaching 2 from the positive side of f of x, well, negative infinity. So that's a nice little factoring and limit problem.